Hello everyone, welcome to my presentation, and this presentation is a summary of my COVID-19 cure rate project. The main goal of this project is to help users explore the global 19 recovery trends and use different machine learning models for production. A COVID-19 recovery dashboard was built, an interactive web app built on Streamlit and driven by machine learning. About methodology, and there are three methods mainly used in my project. First one is data preparation, and the next one is data processing. Third one is machine learning model, and then last one I develop a dashboard. Those three COVID-19 data sets were combined. They were connected by features such as date and country. And I use many methods to process the data to better train my machine learning model, such as missing value handling, outlier detection and removal, normalization and standardization, engineering, correlation analysis, and the last one is final dataset preparation. And I use regression, random forest, and neural networks to machine learning training. And the last one is dashboard visualization. It's built on Streamlit. The key finding is that when we were doing model selection, we found that neural networks and the random forest maintained a high accuracy in predicting the cure rate of the epidemic. Since random forests are good at capturing decision boundaries and feature interactions, it can easily detect this deterministic relationship. So it performs well in predicting the cure rate. However, the filters used to calculate the labels may have a data leakage problem. And in addition, I found that high testing density is associated with high tracking rates. Countries with higher testing densities train to have more complete and timely cure data, resulting in higher and more accurate cure rates. This can also be reflected in our Streamlit dashboard. Next one is tool demonstration. For application mainly used in this Streamlit application. The dashboard first displays key performance indicators, which are based on the latest data after our data cleaning. And it includes the average recovery rate, the maximal recovery rates, and the minimal recovery rate. You can see that the average recovery rate of each country is about 65%. And the first map used plotting maps to show that recovery rates of each country. The color dips represents the recovery rate. The darker the green, the higher the recovery rates of the country. And the next one is this map shows that the testing per million population, highlighting the testing differences. This application shows a predict line graph of the historical and the future recoveries. We can select various countries here and future days to make predictions. For example, I select Japan. It shows the historical data for Japan in the indicated time period and our prediction of the cure rate for the next 15 days. Several improvements could be considered in the future. And for example, first one is integrates additional features such as age distribution and adding some hospital data set, ICU capacity, and so on to further improve model performance. Also, it can deploy and update in real time, deploying dashboards to the cloud and connecting them to real-time APIs. Allows for continuous monitoring and forecasting as new data becomes available. Thanks for watching.